if we had a data set that looked like this, we want to drop out 20 items that in this case aren't really items, but they may have been items. There may have been a subtest that we weren't interested in, a set of items that we weren't interested in for this particular analysis. We just take our usual control instructions, add another line in the control area, doesn't matter where it is, item deletion file equals, and then the name of some DOS file, expunge .fill, doesn't matter what we call it, once it's valid name, expunge.fill, and in the file expunge.fill, expunge.fill is just a little ASCII file, DOS text file, as all Bigsteps files are, little ASCII file, which just has in it, what is it, 21 40, 21 minus 40, 21 to 40. So this says, in the instructions it says, there is a file that has information about items we want to delete, item deletion file. The name of that file is expunge.fill. Down in the file expunge.fill, mini little file, it just says 21-40, means delete all items between items 21 and 40. Just drops them out. Now we can add, say we also discover, oh, well, item number 3 isn't any good either. We can just add item number 3 at the bottom to the list. Then later on we say, oh, well, actually, we hadn't noticed, but actually in the middle here, there is an item that we want to get back in again. Then we could say plus 27, meaning reinstate item 27. So we can delete and add items, and we can do the same thing with people. Because maybe we've got our data set with 20,000 people in, and we want to drop some of them out. Well, we could go into the data file and edit them out, actually delete the lines. But that's usually hard work, and it's always risky once you start editing some data file. Something else is going to go wrong that you didn't intend. So, in just the same way as there's an item deletion file, there's also a person deletion file, if you want one, a PD file, which has the same format as this, in which you list the person numbers. Now the numbers of the people are the line numbers in the data file, not your secret code number that you've assigned to each one, like your social security number or something like that. It's just the number in the file. Just like this would be the number of the item being the number of the item column when they're listed sequentially. Instead of the items are 1 to 30 or 1 to 50 or whatever they are. We can delete them. Just going to see if we can identify an example in the manual here. So it's helpful to do if I can find one. Did I have this? Yes, on page 12, item 3, example 3 actually includes an item deletion file. It's a little difficult to see how it works from this, but you can see in the list of instructions on page 12, it does say id file equals example3.idf. I tend to, you choose your own names, but I tend to use suffixes that afterwards I'll remember what they mean. Like IDF corresponds to item deletion file, and then in the section below you can see it says 5820-25, meaning I want to delete items 5, 8, and 22, 25 when I do the analysis.
Where does that file? Where does that file exist?
You key it in. You key it in on disk as a separate little file.
Separate in DOS, separate in...
Yeah, yes. So if you do a directory listing, you will find it. In fact, if you, since this should be, I'm hoping, this is there in your diskette. Is it there?
It's there.
It's there. Oh, good. We're
It's supposed to be IDF is there.
It is.
Yeah.
Good, good. Because all the example files should be there on the diskette I gave you. So this is. So it'll just be a mini little file that you just key in separately. Because quite frequently, if you're doing multiple runs and things like that, changing it around, you may be building a list of items that you want to delete. Item deletion, if you're, say, dealing with several subtests, a convenient thing often to do, say you've got people have taken, say, 200 items, but you know that, in fact, these 200 items are all sorts of different things that people are being surveyed on. Maybe each page has got 20 or 30 items on that relate to something different. But it's complicated to have to set up lots and lots of different small data files. You'd rather just have one big data file and then pick the pieces out that you want. So a way of doing this is in your item deletion file is to say, delete all 200 items. And then reinstate just the ones you're interested in. Maybe for this run we're just interested in items 28 through 40. The plus sign at start means reinstate. 28 through 40, 53 and 55. And it doesn't matter if these are in order or not down here. So that would just bring back, that would delete the whole lot, and that would reinstate these items. The 14, 15 or so that we're interested in for this particular lot. So that can be quite handy if you're examining a particular little sub-construct within the overall situation or example you're looking at. Because then you can just basically leave your main setup, say with your list of item names, untouched, and then just pick out the little pieces that you want for different runs. Okay, there's a couple more things I want to tell you about before I give you the next example to do. One of them is a more complicated method of scoring, particularly suited for if you've got items with different formats or multiple choice tests or something where maybe you deliberately juggle each item response format to avoid people using response sets, something like that. So that on an item by item basis, what is the right and what's the wrong answer, or what's more and what's less changes. So I'll use the multiple choice test example as being a simple, obvious example that most of us are familiar with. Let's turn to the example. Let's see which example should I look at here. Well, maybe we'll put in a little bit of a wrinkle here. We'll look at page 15. Is that, no, page 15 maybe is a little bit too much of a challenge. We'll try page 14. Page 14. Page 15 is about as complicated as things get. So we'll stay at page 14 here. Page 14 is a multiple choice test. I'll just read down the list here. We start off with the comment. The semicolon can go anywhere in this. You can have several of them. Then we go to the just ampersand in, starting instructions, title, an MCQ test, multiple choice question test. 69 items. Item 1 starts in column 10, and the name starts in column 1. If you look at the bottom of the page, you'll see the data. What does it look like the response format, the options, response options are at the bottom of the page? Okay, yeah, lowercase a, b, c, d, and the blanks probably mean that maybe the people didn't get those. Could have been some computer-administered test where everybody didn't get every item, but it was administered in a multiple choice form on the screen, so we get the responses back as A, B, C's, and D's. Back towards the top of page 14 again, you can see we decided to call the items as topics and the persons as students. Now we can only run up to about 6 letters long for those little keywords because of the amount of space we have in various reports where the words item or person are used. So that's why we end up with these abbreviated words like STDNT for student. The next instruction down is one we're reading for the first time. It says tables equals 1. There are 22 sections or tables in the Bigsteps output. And 1 means produce them all. Right, that doesn't matter if the run is small, but once you start running through 25,000 people, to produce all possible output gets, first of all, it takes a long time for the program to produce it, then it takes up a lot of space on disk, then it takes a lot of effort for you to look through, and then it takes a lot of trees to print it. All right, so, and then a lot of filing cabinets to store it. All right, a lot of trucks to cart it away, etc. So we'll be talking about which particular output tables you want and the format of this instruction. The next instruction also relates, NAMLMP, also relates to the output. P file equals example file, example5.pf. What did P file mean? Okay, it's the file with the person's statistics, person measures, basically for use by another computer program. CSV equals Y relates to the format that the other computer program is going to need. CSV means comma separated values. Basically, mainframe and PC programs that can import ASCII files can import them basically in two formats. One is a fixed field format, where here is the person ID, 23. Here is the first value, 1.7. Here's the second value, 21.3. Here's the third value, minus 3.47. And you know what value it is by its horizontal positioning, in that this is in columns 1 through 5, this is 6 to 10, that's 11 to 15, etc. A fixed field format. So this is particularly mainframes prefer this format. A lot of PC programs, for instance spreadsheets, Systat, and many others, prefer a different format where instead of having things in fixed columns, they use a separator. So that the same data, say to be imported into Lotus, might be preferred to be in a format like this, where the numbers are all adjacent, but they're separated by commas. This is called comma separated value, or CSV format. This is a fixed field format. Now the fixed field is the default for Bigsteps, but if you prefer this format, because it's easier for the program that's going to handle the data, then you specify CSV equals Y, and the P file and the I file will be produced with commas between the values instead of in fixed column positions.
Yes. You can't split and have the I file fixed format and the P file.
No. One or the other. You can always do two runs. Yeah. I've never been in a situation where I need to do that.
I can't think of one.
No, I've either needed it one way or the other. Actually now, I think probably now if I went back and did this again, I'd make this the default. Because I'm discovering more and more programs prefer it this way. And there's fewer and fewer people who are concerned about sending stuff back up to mainframes. And more who are concerned about importing into other PC level applications. Yes?
We normally put it on the mainframe.
You normally do, yes, yeah, but you're with a big organization. All right, well, you're lucky. It's still oriented to you. All right. The next instruction down, H lines equals N. Maybe we should just, I'm just turning to the index to find out where it tells us about P files, and I see it's on page 66. And here on page 66 is the fixed column format of what a P file looks like, and what it's done is it shows for the fixed format version the starting and ending column of each number. So this is just a file of numbers. But there is a little wrinkle to this. Let me see. I thought I had. I should have printed it. I should have printed a little bit of an example so you could see. But apparently I did not. Because what happens is, it's optional whether in front of this information you have some heading lines. Now, when you produce a set of numbers like this and you have them on your disk, it's very easy 2 days later to have forgotten what they were. So the default is for the program, in fact, to put 2 or 3 lines of description at the start of this file that you can delete out, but that are there like it's a little memo to yourself at the beginning of the file, just to remind yourself what all these numbers are all about, which is easy to forget. But if you don't want to include these memo lines at the beginning of the file, you just say h lines equals no, meaning don't include these heading lines. And that's what I've done back here on page, where we were, 14. It says h lines equals n, or h lines equals no. Again, since the basic responses are either yes or no, the first letter is enough. But if you want to say no, that's fine. And if you're German and you want to say 9, that's fine as well. All right. Unfortunately, if you're German and you want to say ja, that doesn't go so well. I have to say ja. All right. Let's skip on page 14. We'll skip over the next few lines down to where we get to codes. So it says codes equals ABCD. As you noticed, ABCD were the valid data responses. Now, in this case, there are also blanks in the data file. Now, we deliberately haven't included blanks in the code statement. Now, the way the program works is, if it's in the data file and it's not in the code statement, then it is ignored. It's treated as not administered. It's neither right nor wrong. It's just treated as truly missing. Missing in the sense of not administered. We don't want to either give it credit or debit, either way. So it's not, if we'd included blanks in with the codes, which is what we were doing with the pluses and blanks on that first example, then blanks would have been a wrong answer or a potentially wrong or right answer. Here, because blanks aren't included in the code list, they're neither wrong nor right, which is what we want for computer administered text. So there's a difference between, in the codes list, we only put responses that we want to be either right or wrong. Anything else in the data file is neither right or wrong. It's just ignored. The instruction under the codes, you see it says missing, MISSNG, that's short for the word missing, equals 255, is in fact the default. What it means is missing data values, in other words, values not in the codes, are to be treated with this code number 255. The code number 255 means ignore. Now, this is the default, so you never need to type this. I put this here just to be explicit. The other usual option is to say missing equals 0. Now, this is handy if you say you're optically scanning in start, but you're not sure what your scanner is going to give you if you say got an answer sheet which is, say, double marked like that. Now, often when an optical scanner, optical mark reader, gets a response stream where 2 blocks have been marked, what it does is, it doesn't give you an A, a B, or C, or a D, which is what you would normally got if only one had been marked. It gives you some curious symbol, something funny. But you often don't know what it was, because you don't know what scanner they're actually going to use to scan this form. And maybe on the bit of the data file that you can see, this hasn't happened. But you know somewhere down in the middle there, this has happened. There's this funny symbol in the data, but you don't know what it is. So you can't include it in your codes list because you don't know what it is. But you do know that it's wrong. Alright, so in that case, what you say is missing equals 0. That means anything not in the codes list is to be treated as wrong. So any funny stuff that happens to have come through is to be treated as wrong. What we've done in this example is to say not 0, but 255, which means any funny stuff is to be ignored. And that's the default. So any peculiar stuff. So we've got the option here of, if you don't know if it's a blank or if it's something else strange, for instance on an optically scan, on a standard multiple choice test, a blank would mean the person didn't answer, and the usual default there is to treat it as wrong. Yes.
In other words, if the missing equals 255, that particular data is not analyzed, treated as missing.
Yeah, in other words,
Yeah.
if you have a response like that, you've taken a shorter test than everybody else.
Okay. Now, if missing equals that symbol,
Zero. Yeah,
then it would mean that that is treated as an incorrect answer.
exactly. Yeah.
Okay. So the person will get a score of 0, whatever. I mean, incorrect answer please.
Yeah, yes, you get an incorrect answer. That's right.
Thanks.
Okay. So if everybody is supposed to have taken the same test, then you probably say missing equals 0. But if people are allowed to take a different test, depends on the situation. Right, now I want to get down to the next line below, which says key 1 equals. We're on page 14 still. Key 1 equals, and that long string of letters that I had to print in a smaller typeface in order to squeeze them into the page here. Okay, this is the multiple choice test scoring key. What it says is these are the codes for each item which have been scored 1. And as the original test had 69 items, there are 69 letters on this one, key 1, and it says the correct answer to item number 1 is D. The correct answer to item number 2 is C. What's the correct answer to item number 69? B. The right hand, the last letter on the right. Okay, because it's supposed to be 69. I haven't counted, but I think I probably got this right. Okay, so this is how you enter a multiple choice test scoring key. And so, basically speaking, there are other ways of doing it in the program, but this is the usual way. You just got the response string, and so consequently you don't need to rescore the data. It will accept this sets of letters and numbers, and you can score it. And consequently, this also has the advantage that when later on you discover that in fact the wrong option was marked correct on item 23, you can change the scoring key and re-analyze. So it's simple. You don't have to go back and somehow reconvert the whole data. Wherever possible, we try not to have to change the data matrix after you set it up once. That's so pretty thing to do. Such a pretty thing to do. All right, any questions on this? I think we're about ready to try task number 2. At which point we will... Okay, yes. Task number 2 starts on page 31 of the handout and covers the last page and a half. Let me make it even more dramatic for you. Here we go. Let's see. Nobody reads Swedish, do they, by any chance? Good. All right. What I'm giving you here is a multiple choice test. It's a Swedish language test. The first part, I'm not giving you the whole test, but the first part of the test is shown on page 31. Okay, 31 shows of the handout shows the first page of the test. And it's a Swedish language multiple choice test, as you can see. One of the things you're going to need to do is to somehow identify each item in a way that is sort of going to be meaningful. It is possible, even though it's in Swedish. All right. Without too much effort. I'm not, okay. Then, what I've given you on the last page is, in fact, the optically scanned scoring key for this test, which is a double-sided sheet, which is the last page of the handout. Okay, so this will give you the scoring key. And I have given you an actual response sheet of real data by a real person. Okay, so this will be, you can use to format a data record. Now what we're going to assume is that you have one of these modern programmable optical scanners that enables you to shuffle things around a bit. All right, so you don't have to So you're able to tell the scanner where to put the item response string and where to put the person response string, and to stick the back and the front of the sheet together, so you don't have to worry about all that sort of formatting stuff. Alright, so the challenge is to write the control file for this data set. Alright? Anybody feel that they don't understand the assignment? Okay.
To score this data set.
Pardon?
To score.
Yeah, to score this same thing, similar.